Hopefully it's helpful for both. So when I do say something dumb on the recording, just laugh and go, oh my God, my instructor's a dork. On the discussion board, I have added something, and I probably will throw in some points of some sort. I'm not sure really how. Because one of the things I got to looking at people's assignments they turned in, and I'm going through them, and I want to see if we can put some comments together and help each other. And so later on in the discussion board, you'll see that you're using that same skills, that same thing. Well, I think we might use it for this week and try it out. So I put a new week 2 show and tell up where I ask you to post your flowchart in the pseudocode. But more than that, what I really want you to do is look at what other people have done and constructively offer criticism, thoughts, ideas. How could this have been done differently? How could it have been done better? How did you solve a problem that they didn't get to? Because when I looked at them, some of these were pretty basic, and that's not a bad thing. We're trying to get you in this mold of how do we start breaking apart and thinking like a computer. But some of them were to the point where it's not as useful as it could be. So I've got a couple of things I want to go over and look at with them, and I'll give you some examples. We have to be able to break down a problem so that a computer can understand it. Now, we're going to introduce some new things this week to make life a little easier. And one of those is when we have a three-way decision, how do we actually solve it in a computer? How do we do? We know that we can only ask two questions, right? A yes or a no. So how do we solve a question that needs three pieces? And that seems to be one of those that's kind of hard to do. And so there was a program on here that was a little trickier because we've all played it. We've all played Rochambeau or rock, paper, scissors, whatever you want to call it. And we know how it works in our brain. But it's a little trickier to write that decision down and try to figure that out when we have only two decisions we can make. So really what you're doing is making a set of yes-no questions. And so very similar to what I showed you with Excel where I asked that yes-no question, is the grade over 90%? Is it over 85%? We have to make essentially a tree of decision making. And so we're going to come up with some easier and maybe better ways to do it, but add this onto your assignment list for today, please. I also, if you got an email from me, it's probably not a positive one right now, and I try to send out some positive ones also, but I was in my office and trying to send out, when I looked, I have a lot of people not having completed things like the quizzes, the assignments. There's not a huge number of assignments and quizzes in this class. If you miss a couple, it's not great. And your grade will rapidly tumble down. So if you got the email, and I'm not sure, I just grabbed them at random, so I don't know who was in there because I can scale it by grade. You can go in and see your grade. If you're below an 80 or 70 right now, there might be cause for a little bit of concern. The one exception to my no late policy is today, if you can get in the next couple of days, get those quizzes done, I will take those. I will not take late assignments. And the reason, we start discussing them fairly quickly and coming up with sample solutions. If I let somebody turn in an assignment after everybody else posted their sample assignment, that really wouldn't be fair to the rest of the group. So let's talk about what we did last week really quickly. So last week, we looked at, there's really only 3 Lego blocks that we're going to get to use in this entire year. All the way through until you nearly graduate in May for some of you, or that you get to watch other people graduate. There's only 3 blocks. 3 blocks. So, there is a selection. There is a decision, which we're going to talk about today a lot. And remember that decision can only be a true, false, yes, no. It can only have 2 branches on it, however you want to construct that. And then a loop. And our loop we're going to start out with is we do something called a do-while loop. everything in the world could be done with a do-while loop. You'll see that there are some loops that might work better in other situations. But logically, we could do them all with that do-while loop that you've already learned. You guys have already learned the 3 pieces you have for the entire year. When we start coding in Python, it's the same 3 pieces. Everything we do is based on those 3 different items right there. So a selection, decision, and a loop. So I will guarantee that will be a question on a final at some point. So up above was your selection. So here is that idea of our question. It can only have a 0 or 1. Our computer is really dumb. All it can do is say 0 or 1. It's a light switch. Your computer is nothing more than in the case of a couple million light switches all hooked up together. So individually, it's not very bright. And then we have our do-while loop. And the while loop runs as long as something is true. Some condition is existing, some condition is true. So if you think about this as a thermostat, that furnace will continue to run while the condition of the room being cold is true. So sometimes we have to work a little bit on how we have those arranged. So everything can be done, and I did a little bit of just throwing stuff together because remember we always have those start and those stop endpoints. Those where we snap in our modules, and we can snap them in. So here we've got a selection, followed by a decision, and then followed by a loop of some sort. So here we have an example of some kind of a game. So, throw the dice. Now, could we go into more detail and say, read the dice back in? Yes. But for this case, we're going to say we're going to throw the dice. Move token number of spaces equal to the sum of the dice. Here's my question. Did the token land on go to jail? What game are we playing? Monopoly. Alright, so if it did, then I go immediately to the jail square. But if not, I ask my next question. Did token land on chance or community chest? Follow directions on the card. If no, follow usual rules for the square where token landed, buying property, buying land. So notice we had a multiple choice question, and that's how we solved it with a set of yes/no questions. So, I left this up there so you guys can use this in the future so you'll be able to pull up these PowerPoints and look at it. That's one way we can solve those kinds of questions. We're going to, well, let me go back a little bit first before we do that. Let me come back out of here. So I was going to show you a shortcut, but let me go through some of the other stuff before we get to a shortcut. Shortcuts are good, but you have to understand what's behind the shortcut. So we're making decisions this week. We're talking all about this decision module. How can we do things easier? There is a term you're going to see called Boolean. And a Boolean decision really is a yes or no decision. It's just a fancy way to say that. So if you hear the term Boolean logic, well, it really means you're just evaluating yes or no. We're going to talk about relational operators, comparison operators, which you guys all know. But we are going to introduce a couple of new items for most of you. Now, I think I have a science person or somebody in here, don't we? So you're going to have possibly have seen some. You've seen a truth table before? You have not. Yes, I am going to. No. So we're going to talk about and ors. And that really is we start talking about how the computer actually starts to think inside. We're going to talk about a range, and then how do we combine things? We have that order of precedence. So the first week we had an assignment, and we had to deal with that order of operations. Well, they're not. We're going to figure that out. So the reality is a lot of people, when you say, hey, I got a brand new computer, they're like, ooh, that's pretty fancy and pretty smart. Well, it really is a set of light switches. It doesn't do anything that somebody hasn't told it how to do. Computers cannot think autonomously. Now, sometimes there's some weird things that happen that make you almost think so. If you have an Alexa, for example, in your house, and it now randomly will pop into conversations and say things. But the reality is a computer is super dumb. Can't do anything unless you tell it to do that. We have a couple of different ways to write these decisions. So the decision really is yes, no, 0, 1, doesn't change. What's changing here in this diagram is do we do something? So in this case, we do something whether it's a yes or a no. In this case, we only do something if it's a single alternative. So we write those decisions. They're exactly the same decision. All we're doing is adding an additional piece of code in there. So if it's raining, I wear, what do I wear in the rain? A coat. That would be on the right. On the left, we might ask that decision, if it's raining, I wear a coat on the right. If it's not raining, I might put in, I'm going to wear flip-flops. So we're just adding that to show that we're having two different decisions. And we'll show you what those look like in some pseudocode. So, dual alternative structure. So in other words, we have two things. So we're going to call these if, then, else. So if a condition is true, we do something. Else, we do something different. So a single alternative is then really just an if-then. And we saw those in Excel where we had the ability then to add a than statement. That's how we got that power to keep adding those, nesting those together. So a lot of times we do have a condition we can solve. If you didn't win the game, else I won the game. So that kind of decision making. So, take a look at one. So here we have a program. And so these are, a lot of these will show up in that online textbook or ones very similar to it. So here we have a program that says, all right, let's look at it, an overtime payroll program. And remember we talked earlier about when I said you had payroll last week. What happens if you have overtime? Well, now we're going to take a look and we're going to use our decision structures to figure this out a little bit. So, on the left, if we look at the flow chart, which might be the easiest way to start with this, we have our big set of declarations. So we have hours, pay, hours in a week, and overtime rate. Notice on the left, we have those all capitalized. They're in camel, sort of a camel case. They have a line underneath it so we can separate them. Why are they all capitalized? What do we have different about those when they're capitalized? What does that tell us? We use them as, starts with a C. Planck has one. They're constants. They don't normally change. I was trying to throw out the Planck's constant thing, but you guys all looked at me like, what? All right, so they're a constant. Can we change them in the program if we need to? We could, and most languages will allow that. But what it really is for us to say, hey, this is not going to change, but I don't want to just put the number in the program because that's kind of sloppy and it has that mystery value. Hours in a week is pretty easy to understand. How many of you have been to Europe? Anybody been to... Oh. So let's think about Europe. Do they work 40 hours a week most places? No. Wait a minute. Once again, we're doing something wrong. So what would happen in our program if we just had mystery numbers scattered throughout, and all of a sudden the federal government said, you know, now we've decided that 32 hours is full-time work. Well, we could change it really easily because we could change it in one spot now in our code. But in this case, so we're just identifying that hours are 40, overtime rate is 1.5. More likely in our country, we'd have a decision that overtime is going to pay 1.2 instead of 1.5, right? We kind of push the idea that we need to work more instead of working smarter. So, input name, hours worked, and your pay rate. Now, even though it says an input, does that mean that somebody has to physically type that? Could that input come from a time clock system or something else? Yeah. Input just means it's coming into this module somehow. So we get our pay rate, we get our hours worked, and we get a name. And here we ask our first decision. So this is a dual selection, so it's an if, then, else. So hours worked greater than hours in week. So did you work more than 40 hours? If the answer is no, then pay is equal to hours worked times pay rate. Comes down, outputs your name and how much you made. On the other hand, if you worked over 40 hours, it does some additional calculations. And what this case it does, it says your pay rate that you put in times hours in a week, times 40, plus, then it's going to subtract out hours worked minus hours in a week. So if you worked 47 hours, it's going to take 47 minus 40 to get your overtime rate times the number of hours. Are there other ways we could have constructed that? Yeah. That's just one way we could do that. So this is that decision. It's asking a question of, did you work more than 40 hours in a week? Sends your name, sends your payout. So if I look, though, over at the pseudocode, here's where some of this blocking becomes important when we're looking at pseudocode. Notice how we have a tag called declarations, and everything is indented to show that that's a block of code. So all of those are one block. And most languages, including Python, work on that idea of blocks of code by indent. So input name, hours worked, pay rate. So we combined those, we got our data. And then here is our question right here. So if hours worked are greater than hours in a week, then, and notice we indent that to say that that's a block of code, then pay rate equals, then we have an else, and we have indented from that what happens in the else statement, pay equals hours worked times rate, and an indent. So that block is how we identify those different pieces. So we can make decisions the same way. So if I pulled up Notepad here really quickly, and I wanted to look at something, so Notepad. Again, not the greatest tool in the world. There are better ones, but I wanted to write an if, then, else statement. So if, and let's just pretend we're going to do something here. So grade is greater than, and I'm going to put in the mystery number. So if I say a grade over 90, what does that tell you about our grade? So I'm going to then send congratulations for A. And then I'm going to have that else. And then I have to end it. That end if says, that's the end of my code. So these indentions here say this is all a block. So I could do several things. So I could send flowers. I could send chocolate. cancel class for rest of semester for you. So I could do all of those, and those happen. This entire block will run if that grade is above a 90. And I can write those blocks so it doesn't have to be just one thing. So go back up here. So else, so if you don't have a 90, then these other things will happen. Send note to parents, send note to, so that is kind of how that if-then statement works. So we can also add later on, we can add some other conditions, and I'll show you how we can do that in a little bit. We can make this even more powerful. But right now, we could break these things up and pretty easily. So I don't want to see a show of hands because I don't want to embarrass anybody. But if you've been on, for example, or what do we call it now, the downgrade list, or whatever we happen to be calling it at the time, early warning, a list of activities, it's kind of generated that. But do we generate it on a grade of 90? No. We usually don't send things to people that have a grade of 90. But if you're below a 60, does that trigger things to happen? So now we have all kinds of processes in place. For traditional age college students, I will say though, we used to actually send a letter home to your parents. And that used to work far better than sending you an individual note. Because parents have some motivating factors that we can't use at a school, right? Now, when we send the 40-year-old guy a note home to his mom, that's always kind of weird. So we have to be careful with that. But that's what an if-then-else statement looks like. It's not hard. It's just we got to kind of break things down and not panic and go, aha, I need to break this into 2 steps. I need to do it in what we call Boolean. So usually we call these true, false, 0, or 1. So 1 is on or true, 0 is false or off. That's pretty easy. We only have to deal with 2 numbers, 0 and 1. Well, we also have a couple of other things we're going to do, is we're going to do comparisons. And you guys have all seen most of these. So here's one of the problems with almost all of our language and programming and where it gets a little confusing. The very first thing we do is an equal sign. Well, we've used equals already, haven't we? But we haven't used it as an equal sign. We used it as an assignment operator. Some computer languages will do things like 2 equal signs to say that it's really an equivalency operator. Or they will have picked another number or another sign for the assignment operator. But 99% of them use the same thing. So it's an equal sign is either are things equal or is it an assignment operator. So we have to be careful with that. And that's one of the things that gets confusing to people is whether it's doing something or whether we're asking that question, are things equal? So we have the equal sign. We have a greater and a less than sign. Well, those work both exactly as you would think they work. Greater than. Here's where it gets a little tricky. And we already found this out with our grades, where I said, oh, greater than a 0.9, and yet I put in a 0.9 and you didn't get an A. So oftentimes we have to do that desk logic. We have to decide, do we really need a greater than or equal to operator? And so if I'm asking the question, is your grade for an A 0.9 or above, what I'm really saying is greater than or equal to 0.9. A less than or equal, And then this one is a little different. You may not have seen it, but logically I think you can understand when I put the two symbols together, what it really say is are not equivalent. So we're just asking that question. So 0 and 1, are they equivalent? No. So what is the output of that statement? And that's where it gets a little tricky. There are some other ones. So you may have used the exclamation mark and the equals sign to say not equal to also. So those are our basic set of relational operators. So here we're asking that question, is customer code not equal to 1? So here we're saying, here's a discount. So in one case they get a 0.25% discount, in the other one they get a 0.5. And the question is, if customer code is not equal to 1, then discount code equals those two values. Can I rewrite that differently? Could I write that differently? So let's think logically. So if it's a customer code of 7, is that equal to 1? No, so they get a 0.5% discount. What if I rewrote that? So it said customer code is equal to 1. What would I have to do to this operation? Yeah, they're essentially switched if I do that. So sometimes it takes a little bit of brain stopping to think, oh yeah, I want to accomplish this. What is the best way to do that? If all the rest of my code uses not equal to values like that, and all of a sudden I throw in one that's equals, I probably got an issue. I want to be consistent in how I do my logic. The saying things are not equal to takes a little bit of getting used to. It's very much like we have a lot of questions on tests that are which one is not equivalent, and it throws people for a loop until they get really good at test-taking strategies. So, that is an example of using a Boolean logic. It doesn't look that hard, does it? Everybody say no. So, same thing here, we just flipped it. If we said customer code is equal to 1, it logically does the same thing. If what we're trying to do is only those people that have a customer code of a 1, maybe they're the special customers, they're the VIPs in our club, whatever, they're the only ones that get a 0.5 discount, it does essentially the same thing. So, we have a negative example. So there's our negative comparison. There's our positive comparison. They logically do exactly the same thing. Customer will get the same discount in either way. Well, we've already ran into it when we looked at our games and different things. We know that we have a couple of times where we need to create a compound. In other words, there's more than one decision that needs to be asked. So let's pick on athletes. Do we have any athletes in here on our college campus? Oh, I got a couple over here. Got baseball, we got football. We got no female athletes in the room. That's interesting. So we're going to pick on football for now. So in football, to be eligible to play football, is there more than one thing that has to happen for you to be able to play football? Yeah. So you have to have. So there's a lot of pieces to be eligible for. Let's take it to the NAA. Well, now we're NAIA, but to be able to play for the NAIA, are there multiple things that have to be? Do you have to be male to play football? No. All right. So, In the NFL you do. They have yet to come out with that. But do I have to have a grade point over, is it a 2.0 or something? 2.0. Can I have played more than 5 seasons? No. You can't play forever in college football, unfortunately. So there are multiple decisions we need to combine together. So we need to figure out a way to logically put a couple of these things together. Let's look at a scary looking piece of code now. This looks a little scary because it looks different than what we're used to. But really, what we've done is we've nested a decision inside of the other decision, where we had an alternative item. So normally it was just something to do. We put an entire other decision inside of it. So these are nested decisions. So our logic here, we have a lot of pieces in our declarations. Items sold, value sold, bonus given, items minimum, value minimum, and bonus. Most of us have either worked in retail or you can envision working in retail. To get a bonus, you either sell a certain number of items or a certain value of items, and in some cases you may have to do both. If we have to do both, that means we have to sell a certain number of items and they have to be a certain value. So think about a salesman at, what's a store we all go into? Nebraska Furniture Mart? Okay, we can all picture Nebraska Furniture Mart. Evil place where they sell all kinds of things. So that salesman gets a bonus at Nebraska Furniture Mart if they sell over, in this case, they have to sell 3 items and those items total have to be $1,000. Well, that makes sense. Because could I, as a salesman, sell 3, what do they sell in Nebraska Furniture Mart that's cheap? I'm trying to think. Could I sell 3 little kitchen appliances that aren't $1,000? Sell 3 blenders. And there probably wasn't $50 worth of profit on those 3 blenders. So, yeah, I can see why I wouldn't get a bonus. But if I sold 3 couches, is that going to be over $1,000? And I'm going to get my $50 bonus. So we're trying to make sure that we meet both criteria. So as we come down, let's kind of work through here one. So if items sold are less than 3 items. So I only sold 2 couches this week. Do I get a bonus? No. So I come down here to items sold. It exits me out and it says output name. And what's kind of confusing because it says bonus given, but what it really means is that I'm going to have a 0 in there, right? So I didn't assign anything into that bonus. On the other hand, I had a really good week at Nebraska Furniture Mart. I'm selling couches and chairs, and I sold 5 items because I found sucker customers like me that wander in and go, ooh, I need that. I don't know where it's going to fit, but I need that. So I sold 5 couches this week. So I hit my first question. So I hit items sold. So is 5 greater than 3? Yep. So I moved to my next question. And now, is the value sold greater than value minimum? So I sold 5 couches. Each one of them was $1,000. So I sold $5,000 worth of stuff. Is 5,000 greater than 1,000? Yep. So if that's true, it moves to the true category. And bonus given equals bonus, which means it's now equal to 50. So I get my name and I get a $50 check. Does this seem to make sense? Not horrible yet? So these ands are a way we can establish things. In our brain, we know we need both pieces. But this is the way we have to logically write this. So if I look at the pseudocode, declarations don't look any different. Input doesn't really look any different. But notice what we did. We put an if statement, then another if statement inside of that. That's exactly the same thing we did when we constructed that Excel sheet to show on those if-then statements whether I got an A, B, C, D, or F. So we're just nesting those together. If you do not very carefully make sure your indents are correct, though, you're going to get confused. And the computer will get confused. And those indents allow it to work correctly. So if I don't get the indents right in Python, you may get a bonus whether you've sold the right number of things or not. So the computer, though, here we're going to look at how we can make it more efficient. So in this decision here, to me getting a check, does it matter whether I check for how many items are sold or how much the value is first? So do I get the same result whether I put either one first? Well, yeah, I get the same result. But think about this. That computer takes a little bit of time to make each one of those decisions. Decisions take that computer having to think, I'm going to make a comparison and then output a result. So what I'd like to do is structure this to be as efficient as possible. And what I want to do is dump as many people out immediately as possible. So if I know historically that what keeps people from getting a bonus is the number of items sold, most of my salespeople only sell one item a week, I will do it in this order because it dumps the greatest number out. So I only have a few people that I have to ask this decision on. On the other hand, if I know historically that most of my salesmen sell 100 items, but it's the value that keeps most of them from doing a bonus, I might well reverse the order of those so that it ejects people as quickly as possible. So, this simple of a decision isn't probably that big of a deal for our computers today. But think about something like the IRS. They're going to process millions and millions of these horrible, evil tax returns coming up. If we could make their processing faster, could you get your return faster? Yeah. So sometimes we really have to think about efficiency and how that's going to work. Logically, it doesn't make any difference. Logically, both conditions still have to be true. So, but we can a lot of times look at it so we can tweak our program to run better because we know which one of those decisions we run first. Because we don't necessarily have to run both of them. We don't necessarily have to run both of them. So, here's that same example. Here we have coming in 1,000 salespeople. Nebraska Furniture Mart's got a lot of salespeople. And in the first case, we eliminate 100 people, and then we eliminate 450 people in the second one. So the bonus comes down to 450 people actually get a bonus. Okay. So here we have one option, and what you can think about is how many times does each question run? How many times does the item sold greater than items minimum, the top one, run in this scenario? So it's got 1,000 people coming into it, so it's got to run 1,000 times, right? This one has then 900 people coming into it, so it's going to run 900 times. So this configuration had, you had to ask 1,900 questions. Or answer 1,900 questions, comparisons. Does that make sense? So, we have 1,000 coming in, so we know we're going to have 1,000 decisions up top. And then, because 900 people then come into this question, so we're going to do 1,900 comparisons. And each one of those comparisons takes a little bit of computing power. Let's compare and contrast it to this. So same number of people, same values, but let's see what happens. We still have 1,000 questions are going to be asked at the top, or comparisons, right? We have 1,000 salesmen dropping in. But look at this. We eliminate 500, so 500 go flushed out right away. How many people are going to enter into this for a comparison, the second line? 500. So in this model, with this set of data, we have 1,900 comparisons having to be made by the computer, or 1,500. Is that a significant difference? Would we notice the processing difference of this one decision? Probably not. But if there are a series of these, and we route these and we tune this correctly, you can make your system significantly faster. So when we talk to like database administrators, these are the kinds of things they're working on, is how do I tune this based on the data I'm given? If I didn't have this data, do you have any idea which way would be more efficient? No. And logically, does it get the same answer either way we do it? Same people are going to get a bonus. Same people are going to be happy because they got this big extra check. So, we can almost always ask either question. The general rule is this. We try to ask the first question is the one that is least likely to be true. So I know that's kind of a weird way, because we do a lot of negatives in here. The least likely to be true. In other words, we're trying to peel out as many people originally as on the first decision. So notice the first one we got rid of 100 people. The second one we got rid of 500 people. This option is the one that the first question was least likely to be true. So that's kind of one of the general rules we try to put into it. Is everybody's head exploding already now? Pretty much. It's not as tough as it seems. If you've read the book, you look over it, but it's that negative piece that tends to throw most people. So that's why we work on a lot of this. So, logically, we can ask all kinds of questions. We can add additional AND operators. Are we limited to just two, like we just saw? No. We can add additional pieces, and you could nest that 3 or 4 or 5 levels deep if you wanted to. So, same question here. So items sold, bonus given. So here we have that AND operator, and this is a little simplified up top, maybe makes it a little easier to see. So if items sold greater than items minimum, then we have our next question. If value sold greater than value minimum, then bonus happens in some case. Notice we have 2 end ifs, and they're at the appropriate indentation lines. One of the things when you're writing these that will help, if you print it out, if you're one of the people that really likes to print things out and see it physically in front of you, use highlighters. And you can highlight everything inside of a code block different colors. And sometimes that will help you understand what's going on here. Because if I forget an end if, it can create problems. So these very simple little structure issues can sometimes cause issues. So here's our first shortcut. We're going to assume that you guys can all make the logic for that nested AND statement. If you are comfortable with that, you can do this. Same value, same results, same values will end up at the end of it. Same values come out of it. We're just combining that into one decision. So we're saying, all right, we know that just to make life a little easier, and so we combine it into one if statement. So if items sold greater than items minimum and notice we always capitalize that, and value sold is greater than or equal to value minimum, then bonus given equals bonus. This is the same thing we just saw. We just made it a little shorter and easier to deal with. Everybody likes little shortcuts? Life is easy. In fact, in there, if you wanted to add a third one, so maybe this place that we're working on, not only do they require items sold greater than items minimum, so they have to sell 3 items, and they have to sell $1,000 worth of items. In this place, the only bonuses are given to males. Does that seem fair? You guys are all looking at me like, whoa. Alright. It may not be a valid or useful way to do it, but could we put it in there? Yeah. And sex equals male. All 3 conditions would have to be true. What if we put in there you had to have been employed over a year? Could we do that? Probably a little better comparison. Yeah. So we could put nearly an unlimited number of and statements and combine them together. And statements meaning everything has to be positive in there, both pieces. So here's the scary part we're coming up. Everybody ready? I'm going to flip over to something that you have not seen before. Here's what it sounds like. This is something called a truth table. A truth table looks at each of those individual comparisons, and we look at what happens overall, what has to happen. So, sometimes we write it differently, and I'll show you another way we can write this. So, condition X, condition Y. So, values above 3, or number of items sold, value of items over $1,000. So, X's and Y's. X and Y, then, whether it's true. So, in a and statement, both parts of that, or really all parts of it, have to be true, correct? So, for my entire sentence to be true, or evaluate to a 1, I have to have both pieces of it are true. Any other condition, so if it's false, false, equals false, false, true, false, true, false. So the only way it can happen is if both pieces of those are true. The only way we get our bonus is if both pieces of those are true. So this is what we call a truth table. Well, we may also write it a little differently. I'm trying to think of which program would work really well to do that. I'm just going to use Excel because it's handy and I like Excel. So we can also write that truth table rather than true falses. Let's write it this way. So let's call our truth table. So same thing. So let's write this one as an X, this one's a Y, and this is X and Y. So here I have, so true is a 1, yes is a 1, that means that is a 1. So oftentimes we write them this way. So that's a truth table for a and statement. Let's think about if we expand this just a little bit. I said you can have more than 2 conditions have to be true. So we said this is minimum number of items. What if we added a third category? And we talked about a few of them. So what if we did the greater than 1 year? So in other words, this employee has to be there greater than 1 year. So we'll call this one N. So now I have a set of values for this also. And so the only way that that is going to evaluate true is if all of those conditions across there are true. Should I make that a little bigger? So we've added another condition. So if I have a 0 anywhere, so even though in this case he's been there over a year, or her, does that change this final result? No. All three have to be 1 for that to be possible. Now, there's additional permutations in here we're not writing down, but what I want you to see is in an AND statement, all of them have to be true. So think about, to get a tax refund, what do you need to have happen? Are there multiple things for a tax refund? So, I have had to have paid more than I owe. So, there's a 1. What else has to happen? Is that it? Ooh. Their taxes are tough. What else has to happen to get a refund? What other things have to happen? What if I am behind on a student loan payment? There you go. So if I'm behind on student loan payments, do I get my... No. No. So again, that would mean I do not get that final result. All of those conditions have to be true for me to get that student loan payment. Or that income tax refund, sorry. So there's a lot of those in there, and they all have to be true for you to get those. So if I'm behind on a child support, can they take that and you lose your... Yeah. If I didn't file last year, what happens? They're cranky about that, aren't they? What if I'm male and I didn't register for selective service and I'm a U.S. citizen? In other words, I didn't register for the draft. Do I get a refund? Yeah, there's all kinds of pieces in there. So these are kind of interesting to build and to look at on this idea of truth tables. So that is our AND truth table. So whether we nest them or we short circuit them, so in other words we combine them, they resolve in exactly the same result. Exactly the same result. The computer, even though we shortcutted them, they're going to get exactly the same thing. So we do have a couple of things that we do have to worry about. We have to make sure that we work these in the correct method. And so if I did this, so now same questions, but I'm asking them, instead of nesting them, I ask them serially. So in this case, what's going to happen? Items sold, well, if I have enough items sold, I get a bonus, even though I may not have enough value in them. Or even if I didn't have enough items sold, but my value is greater, I would get a bonus. So this case, if we did it this way, if I just glanced at it, does it look like we're asking the same questions? Because we're really asking the same questions. But our bonuses are going to be significantly higher because we have all these people that are going to not meet both criteria, and we're going to give them a bonus. Now, that's actually an example of one we'll look at in a little bit, a different logical structure we'll probably get to on Thursday. So, In this case, what have we done here? We said, if items sold greater than or equal to minimum for bonus and less than or equal, what? What are we missing in there? We're missing that item value. Because right now, it's going to do a comparison of, is this value compared to this question? And it's always going to then be true. Not necessarily what we were looking to do. And so here, we've rebroken it out. And in fact, what I like here is I like the use of parentheses in there to kind of make it a little clearer. So that tells me very clearly that this item has to be computed, and this item has to be computed, and then we compare those. So if this is a 1 and this is a 1, do we have a 1 and a 1? The entire expression becomes true. We are going to leave you with the idea of an OR statement. So we did ands, we looked at ands, and we'll work on them again. But I want to leave you with an OR decision. An OR decision means either one of the conditions must be met. So when I say OR, so what if I said, you have to sell 3 items or your value has to be greater than 1,000? Is that going to change our logic a little bit? Are we going to get more people getting bonuses? And I will leave you with this today. That OR decision, quite frankly, are we going to get an OR decision really out of this? Is that going to give us all the people that have sold more than 3 items and all those people that sold more than $1,000 worth? Yeah. So we have to be very careful if we need an AND or if we need an OR so that we don't end up with some kind of a dilemma where we're giving out extra bonuses. That wouldn't be good. What if we gave out extra credit that way in a class? Yeah. So some people that give out extra credit in courses have that requirement that you have to meet some requirements. Usually you have to have attended all of the classes, right? And you have to have done all the homework before you get the opportunity to get an extra credit assignment. If I changed that to an OR, you would have had to either go to every class or you turned in all the homework. So, ANDs and ORs are kind of opposites in how they work, and we need to make sure that we are evaluating those guys correctly. All right, we're going to finish up on logic on Wednesday. If you turned in your assignment for this week, make sure you go on the discussion board. I got to send an announcement out. So there is a discussion board so that you can look at it and evaluate it. If you notice, I did not directly assign points in there yet. This will probably be the first of our extra credit. Hey, how did you help people out? Because at some point in here, you guys are all going to need the assistance of somebody else. Unfortunately, I can't be everywhere at once, and I've already figured out this schedule this semester. There's days I'm supposed to be in 3 different committees and 3 different times at the same place. Somehow I've gotten a little overscheduled. So, make sure you post that in the discussion board and look at what other people have done. It may surprise you. Come up with some ideas for how to help them. So we're kind of breaking you in for when we start coding what we're looking for. So, there are no points for turning in the material. There are points for assisting others on it. And they will be extra credit points. Everybody likes extra credit points, right? Start out the year a little above 100 and it's good. A little above a 90. A little above a 7. So wherever you're at, get some extra credit points. All right. I will see you guys on Wednesday. If you have questions, ask them. The what? Yes, it's a show and tell thread at the very top. Yep, I just created one and moved it way up to the top so you guys could post that in there and take a look at it.